Good afternoon, everybody. Welcome to this side event. I know it's a very busy schedule today with lots of competing events. This side event at the World Meteorological Organization IPCC Science Pavilion, is that better? Is a collaborative effort between WMO, the IPCC, UN Environment, and the Global Carbon Project, which today released the Global Carbon Budget with a lot of publicity. My name is Claire Nullis. I'm in the Communications Department at the World Meteorological Organization. We hope this event is being live streamed on Facebook. Time will tell. So please, any tweets, any posts you can make will be much appreciated. So without further ado, I will hand over to Claudia Woloschuk, who's with WMO's Global Atmosphere Watch program, and she will talk to you about the WMO Greenhouse Gas Bulletin, which we released 2 weeks ago. Thank you.
Hello. Hello, good afternoon, everybody, and welcome to our event. I'm happy you made it here, despite the very busy schedule. Just 2 weeks ago, we have released the new WMO Greenhouse Gas Bulletin, of which also hard copies are available outside. And I will now give an introduction of the most interesting findings. So we have seen that the main greenhouse gases, here we can see carbon dioxide, continue to increase. This is observation through 2018, and it basically increased at the same growth rate as average over the past decade. So there's no slowing down in greenhouse gas concentrations. Basically, this is the concentrations. So this means this is not the emissions. This is what stays in the atmosphere after everything that is emitted, and all the things such as forests and so on have taken out the other part. So this is really what is now in the atmosphere, well, what has been in the atmosphere through 2018. It has increased by 2.3 parts per million from 2017 to 2018. And now let's have a look at the next one, at methane. Also, methane has continued to increase. It has now reached a new high as well of 1,869 parts per billion in 2018. And the increase from 2017 to 2018 was higher than both that observed from 2016 to 2017 and also than that over the last decade. And some additional measurements suggest that it may be related to tropical regions, this increase. Of course, in addition to the emissions. And the third most important long-lived greenhouse gas is nitrous oxide, where we can see here that it has, as the other two ones, also continued to increase. So in none of the three major greenhouse gases we can see any leveling off or let alone decrease of the concentrations by the end of 2018. So its atmospheric concentration in 2018 was 331.1 parts per billion, and that was higher than what we have observed as a growth rate before, and also than the average growth rate over the past 10 years. So you can see here, there, that it's one of the highest growth rates that has been observed, and the main source for that is nitrogen fertilizer. So here we can see an overview of all the three greenhouse gases, their global mean abundance that we've just seen, but also relative to the pre-industrial, where carbon dioxide is now at 147%, methane at 259%, and nitrous oxide at 123%. And we can also see the increase over the last 10 years, and the increase over the year from 2017 to 2018. And of course, we are interested in the greenhouse gases also because of their radiative forcing. That means because of the warming they are causing in the end. So here we can see the annual greenhouse gas index from the National Oceanic and Atmospheric Administration. And we can see that compared to 1990, which was here, to 2018, there was an increase by 43%. And CO2 accounts for about 80% of this increase. And here we can see how much all the greenhouse gases contribute to the increase in radiative forcing. And since the pre-industrial period, so basically before human beings started emitting greenhouse gases. And there we can see that carbon dioxide is the major greenhouse gas of 66%, followed by methane, 17%, and then nitrous oxides, and then the CFCs and some minor greenhouse gases. Each year in our greenhouse gas bulletin, we have an additional cover story, and this year's it was about so-called isotope measurements. So isotopes are the same element, but of different weight. So there's usually one most common one in the example of carbon. This is the carbon-12, but we have also 13 carbon and 14 carbon. And if we measure their relative abundance, then we can draw conclusions on the sources of greenhouse gases. So radiocarbon is produced by cosmic rays, of which we can see here the time series. When it is radioactive, so it decays, but very slowly. There was a perturbation by the atomic bombs, but now it starts to be useful again to draw conclusions on the sources of carbon. And of course, in fossil fuels, there's no radiocarbon left because by today it has all decayed. So this decrease in radiocarbon points to fossil fuels as a source, together with the decrease in the other isotope, which is a stable isotope, but the plants that were on our planet when fossil fuels, the plants that created fossil fuels were growing, did not prefer to uptake this one. So their combined decrease shows us that a combined decrease in the atmosphere, while CO2 continues to increase, shows us that it's related to fossil fuel emissions. This is just another proof of carbon dioxide increase coming mainly from fossil fuel emissions. All this has been derived from our global network that in the Global Atmosphere Program of the World Meteorological Organization, with contributions from the member countries and from contributing networks, all of these stations have contributed their data to the World Data Center on Greenhouse Gases, where it is freely available, so everybody can actually reproduce these plots if they wanted to, or do further scientific analysis with it. And so, of course, we can see there are some gaps in some regions that we would like to address, but the fact that we can calculate a global average from all these stations, which are far away from emission sources, shows us what the real atmospheric concentration is. Also, we have released this week the provisional statement on the state of the global climate, as some of you may have heard. And I would just like to mention some highlights of it, because in the end we are interested in greenhouse gas concentrations also because of their impacts. So one of the most well-known impact is the increase in temperature. So this is the temperature from the report increase. And we can see that also there it continues to increase. It has been high again. And since the pre-industrial period, we currently have plus 1.1 degrees Celsius. But carbon dioxide also has some other impacts. Of course, all this also causes more extreme events and so on. For more details, I would refer you to have a look at this statement. But also, more carbon dioxide is taken up by the ocean, where we have seen an increase in ocean acidification, which means a decrease in the pH value, as compared to the increase on this side to the increase on atmospheric carbon dioxide, which has been 26%. And I'm sure we will hear more about this in the sinks. But just for some ideas of the impacts of this high carbon dioxide concentrations. So my summary is in principle my first slide. We have another year and another record. So we can see in all three greenhouse gases, the concentrations continue to increase. So I can only refer to the theme of this COP, it's time for action. And thereby, thank you for your attention.
Thank you. Thank you very much for that, Claudia. And after that, I will hand over to Glenn Peters, who's the research director at Cicero, and a very big part of the Global Carbon Project, which this morning has presented the findings of the annual Global Carbon Budget. So thank you very much indeed for making time out of your busy schedule.
Thank you very much, and it's nice to be here. As you mentioned, it's been a hectic day. We just launched the Global Carbon Budget overnight. So far, I think there's been a good response. Some of you may have already seen media stories so far. So what I hope to do in the next 10 minutes or so is to give you a quick rundown of the headline results, and for this audience, go into a few of the more interesting details, I hope. Oops. So this is quite a big effort coming from a lot of people. So I'm the lucky one that gets to stand here and present it, but there's 76 people, let's say, directly involved. We have a sort of a process for who can be authors and who can't be authors. So there's actually a lot of other people who are contributing. There's people out in the ships in the middle of the Pacific right now, probably collecting CO2 data. There's observation stations around, people collecting energy statistics, people trying to figure out what's going on in the land sector. So behind this, there's hundreds, if not thousands, of people that we build on to get this to happen. This year, we have a paper which goes into the data and the details. We have a couple of commentaries which more interpret some of the results on the fossil fuel side. And there's also a lot of resources on the web. If you Google Global Carbon Budget, you should come to that top right webpage there, which will have PowerPoint presentations, the stuff that I'm presenting now, data, figures, and so on. There's also at the bottom right there, the Global Carbon Atlas, where you can go and compare countries, look at per capita emissions, and so on. So what is the Global Carbon Budget? It's essentially a balancing and accounting, if you like, of the sources and sinks of carbon. So we have some CO2 that we put into the atmosphere by burning fossil fuels in the grey, by chopping down trees, deforestation in the brown there. But also the Earth system provides a lot of nice services, cleaning up half the mess that we make, essentially. So about a quarter of the global emissions would go into the atmosphere, a quarter goes into the ocean, a quarter goes back into the biosphere, and about half of it remains in the atmosphere. And that bit that stays in the atmosphere, we can measure quite accurately, and this is the bit that's causing the temperature to increase. I'll go into these little bits and pieces throughout the presentation. Most time I'll talk about the fossil emissions. So the headline result that we had for the budget this year is mainly focusing on what happened in 2019. Of course, there's a lot of detail in the previous years that are relevant and also interesting. But the most newsworthy, if you like, is what happened in the last year. So this year we're estimating that emissions will go up 0.6%. There's an uncertainty range around that, so we can't exclude that emissions could go down. Of course, they could also go up faster than we've projected here. This 0.6% is not so different to the, let's say, the last 10 years, 0.9% per year. Given that the economy has its little ups and downs, there's different weather patterns affecting heating and electricity generation and so on. You do expect some variation in the growth rate. So for me, 0.6% is not really that different to what's been happening in the last years. I certainly don't see any structural changes that would indicate that we're now on a new pathway of lower emissions growth. The 0.6% increase, though, is much better than what we had in the 2000s, where emissions were going up around about 3%, primarily driven by huge growth in China during the 2000s. And it's worth noting, the Paris Agreement, which was adopted in 2015, emissions are probably going to be about 4% higher than in 2015. So no matter how many climate conferences we have, we keep pushing those emissions up. Why are emissions going up? This year in the carbon budget, we've for the first time split our projection into coal, oil, gas at the global level. We usually just do by key regions, but we've extended it a little bit to do coal, oil, gas, which sort of completes the picture a little bit. The brown here is coal, and you can see that may have peaked around 2012. I'd be a little bit cautious in saying that coal has actually peaked. We still have to let some time go and let emissions go down before we can lock that in. But it looks like this year emissions will go down from coal about 0.9%, but this is offset by very rapid growth in oil and gas. Oil consumption continues to go up about 0.9% this year. That's driven by not only oil use in developing countries who are seeking to increase their transport services, but also developed countries, rich countries are still increasing their oil use. Gas has been a bit of a surprise, at least for me. It's sort of a little bit lower in the scale, so we tend not to think about it so much, but gas is really coming along. It's growing the fastest in relative terms and in absolute terms. And from 2012 onwards, about half the growth, or a bit more than half the growth in global emissions is driven by gas. So we need to pay a little bit more attention to gas, also some exciting things to do with methane and so on and so forth. Moving to the countries, it looks like China will have emissions go up about 2.6%, not so different to the last few years. China, there's a bit of a battle between a weakening economy and the government trying to boost the economy through infrastructure investments. Infrastructure investments often lead to more cement, more steel, more coal, and so on. India is a bit of a surprise this year. In the last decade, Indian emissions have gone up about 5% per year. This year, only about 1.8% per year, a little bit more uncertainty than usual around that number. And the main factor that's gone on in India, there's been a little bit weaker economy. They're continuing their electrification schemes, but this year had a very big monsoon, flooded a lot of coal mines, has an impact on coal power generation, but also ensures that hydropower generation can take up some of the slack. So we see a big drop in coal, or a decrease in growth in coal, and a very big increase in hydropower generation. So I would tend to think that this is a one-off, and maybe next year we'll move back to the sort of 5% per year growth rate, but let's hope that I'm wrong, and things are changing in India. The US and the EU, some similarities here. They've both estimated to go down 1.7%. Both have had a 10% drop in coal use. Completely coincidental, but many of the same drivers there. The EU has a little bit higher carbon price. Electricity generation from coal power looks like it could have gone down as much as 20%. We'll have to see at the end of the year when the final numbers come in. That's offset by oil and gas. The US, the trend of the shift from coal to gas and renewables, solar, wind, has increased. So coal consumption has gone down in the US. One interesting thing about the US is last year, 2018, it had quite a big increase in emissions, a bit over 2.5%. This was quite weather related. Cold winters led to more gas use. The warm summer led to more electricity generation, so more gas. And the decrease this year, 1.7%, does not overcome the increase last year. So if you combine those 2 years, the US has gone up. The rest of the world up the top there growing about 0.5%. A little bit lower than previous years, which are around about 2% per year. And the main factor there is a weaker global economy. And this relates a little bit to our method. So if the global economy is weaker, then we'll get weaker emissions for the rest of the world. I should say for the China, US, EU, India, we make those estimates based on monthly data, whatever monthly data we can get. So they're estimates, we have to wait for full year data to come in before we have a definitive answer. I'll skip over this one and move straight to this figure, which shows the top 6 emitters in absolute terms, but ranked in per capita basis. So when you're looking at the increase in CO2 in the atmosphere, what's going on, you need to look at the absolute emissions. But when you want to start to talk about mitigation and how different countries are meant to contribute to the mitigation challenge, It's very useful to look at the per capita emissions, and we will see that the US has very high per capita emissions, although that's trending down, around 3-4 times higher than the global average. Global average is in grey in this figure. We've added Russia and Japan also have high per capita emissions. Interestingly, China and EU have about the same. You can see in this figure it looks like China's a little bit higher than the EU, although I'm not going to get excited about that given the uncertainties. I would say statistically they're basically the same, about 40-50% higher than the global average. And India, of the big emitters, is much below the global average. That doesn't mean that India can keep emitting emissions forever. If we want to solve the climate problem, emissions need to go to zero. That means also in developing countries we have to get emissions to zero. Just might be a little bit slower in India than, let's say, the US or the EU. Moving on to the rest of the carbon cycle, land use emissions. So I'm sure everyone's heard about all the fires in the Amazon. So there was an expectation there'll be a huge increase in CO2 emissions from land use change. We do find an increase. This is a very preliminary estimate. It's based on fire counts in areas where deforestation happens. It gives a round about 800 million tonne increase over the previous year. We'll have to wait for the next year before we start to get land use data to see what transitions have actually happened to firm up that estimate. But let's say the fires weren't a huge outlier compared to the variations that you can have. And certainly if you look at Brazil, the deforestation in Brazil, even though it was higher this year, it's still lower than in the 90s and the 2000s. Not good that it's gone up, of course, but quite a bit lower than previous decades. There's a slight upward trend if you look over the last decade in land use change emissions. I would say, though, this is quite uncertain. You'll see the spread there. Different models give slightly different answers. It's very hard to estimate emissions from land use change. What's the carbon density of different types of land? What are the actual transitions that are going on between different land types? So this is an active area of research. Comparing the two, land use change emissions are generally flat over an extended period, whereas the fossil fuel emissions are growing quite strongly. In the last decade, land use emissions are about 14% of the global total. We tend not to talk so much about the total emissions, adding these two together, because the land use emissions tend to go up and down a lot from year to year, depending on weather, events, and so we'll just end up saying, oh, this year emissions went up 3%, oh, next year they went down 3%. So the real interesting thing is what's going on in fossil emissions, let's say on a year-to-year basis. For land use, you really have to look at trends to see where things are going because of that additional uncertainty. So closing the carbon budget, so as I mentioned, I've talked about the sources, what we're putting into the atmosphere. We're putting CO2 emissions from burning fossil fuels and cutting down trees basically into the atmosphere. What happens to that CO2 into the atmosphere? Not all of it stays there. About a quarter goes into the ocean and about a quarter goes back into the lands, and the remainder, about half, stays in the atmosphere. Oops. So this is ocean estimates of what the ocean is taking up in terms of carbon over time, and you can see since 1960 there's been an increase in how much carbon the ocean is taking up. This figure has both modelling and measurements. I won't go into the details, but you can see there's some spread and uncertainty, but pretty high confidence in the trend. And this sort of grows more or less in line with emissions. So the more emissions we put into the atmosphere, the more the ocean takes up. So the ocean is providing a nice service. This also causes acidification, so it's not a good thing overall. But in terms of CO2 in the atmosphere, the more we put in, the more the ocean takes out. It's a little bit similar on the land side. There's a lot more variation. The land sector gets impacted a lot more by variations in weather patterns around the world. If we have an El Nino, hotter, drier summers or winters, or less rain, more rain, then the uptake on land is affected a lot, but it's generally growing in line with emissions. And this is the difference between what we put in the atmosphere, what goes into the ocean, and what goes into the land. This is the increase in atmospheric concentration over time. You see it's quite noisy, primarily because of the ups and downs in the land sink. But this is growing in line with emissions, more or less. You can't really see that here, so a sort of a technical figure known as the airborne fraction. So we can estimate the amount of CO2 that goes in the atmosphere and what share of our total emissions remains in the atmosphere. So the atmospheric increase divided by our total emissions. You see it goes up and down somewhat, but over time, it roughly stays at about the same level. About 45% remains in the atmosphere. So basically, no matter how much we've put in the atmosphere, how much climate change is impacting the land sector and the ocean, we're still taking up carbon at the same rate in the atmosphere, overall, 45% remaining in the atmosphere. We don't know that this is going to continue into the future. If it doesn't continue into the future, then we're getting into feedbacks, and the increase could, if you like, accelerate in the worst case situation. We do know from El Nino years, when conditions are hotter and drier, for example, in the tropics, we get less carbon uptake, so we know there's some sort of feedback mechanisms going on, but so far at the global level, they're not playing out. So that's an important message, but we can't be sure that this is going to stay forever. And it's the CO2 that remains in the atmosphere that causes climate change. So this is the actual stock of carbon in the atmosphere, the CO2 concentration. Averaged over time, you see the nice wiggle, the ups and downs in the orange line there is the seasonal cycle, more of the land mass in the northern hemisphere, so forests sucking up carbon and releasing carbon as we go through seasonal cycles. Overall, we expect the CO2 concentration to go up about a little bit over 2 parts per million in 2019, which will bring the average for 2019 to be something like 410 parts per million. It was not that long ago that we passed 400 parts per million. And it's this CO2 in the atmosphere which is causing climate change. And that's basically where I was going to end. And I just finished with you looking at the lovely figure of the carbon budget. Thank you.
Thank you very much. Fascinating and alarming. If people who are standing outside, if anybody would like to come in, we still do have some seats left. So I'll just give people time to settle down a bit. Okay, and our next speaker, and thank you very much for coming, is the theme is implications drawn from the Intergovernmental Panel on Climate Change, IPCC special reports. And the presenter will be Yuri Rogali, who has quite a long title, lecturer at the Grantham Institute at Imperial College London and senior research scholar at the International Institute for Applied Systems Analysis. So thank you very much indeed for coming.
Thank you. Yeah, thank you very much. I was asked to provide some context of this, of these findings and draw from the IPCC reports. I will draw from this special report on global warming of 1.5 that was already published last year. So this might not be all too new, but it will provide some context to the ongoing change that the two previous presenters have presented. Just like the previous two presenters and all of us today here, actually, this is not just my work. I'm presenting here work of really a huge amount of scientists. First of all, the authors, 90 authors of 40 countries, another 100 plus contributing authors that looked at 6,000 scientific studies that in themselves were then again published by research teams, more than 1,000 reviewers, and more than 42,000 comments provided by those reviewers. The first message that really comes out of this report is that we understand and we can attribute global warming to human activities. You have seen parts of this puzzle being presented by the previous presenters, also from the WMO. What this figure here shows is on the very noisy gray signal on the left-hand side is not the annual temperatures, but it's the monthly temperatures, so they're even more noisy than the annual temperatures. But what is important here, and is in addition to what you might have seen before, is this orange range, and that is actually the part of the trend that can be attributed to human activities. And as you can see, and the report shows, this is pretty much 100%. And by 2017, our human activities had warmed the world by 1 degree, and we are warming the planet at a rate of 0.2 degrees. That means that given this rate and where we are today, if we continue with this rate, we would be crossing the 1.5 degree threshold between 2030 and 2050, roughly. Of course, this warming brings impacts with it, and this is one of the iconic figures that the IPCC likes to show, which is referred to as burning embers, and they really show that every degree of warming matters. And what you can see here is 4 bars with colors. Each bar represents a different kind of impact. The left one is unique and threatened systems like coral reefs or mountain systems or the Arctic. The second bar is extreme weather events. The third is the distribution of impacts, so how poor and vulnerable populations are disproportionately impacted by climate change. The fourth bar is global aggregate impacts, so how much do we, for example, think or expect global GDP to be lowered by climate impacts. And the last one are large-scale singular events, and that basically means large tipping points, like the disintegration of the Greenland ice sheet or the West Antarctic ice sheet. And then you can see for different levels of warming, you can see different levels of risk. And the gray area, sorry that you can't really see the laser pointer, but the gray area is where we were in 2006, 2015. Each color here has a specific meaning. If it wants to, there we go. White means that it's that risks are undetectable, so we don't really care too much. Yellow, however, means that risks are moderate, and moderate means that risks can be detected and attributed to human activities. The red color means that risks are high, and that means that these risks become of a global nature, so not just, for example, coral bleaching in one reef, in one area, but a global coral bleaching event. And then finally, we have there we go, very high, or the purple color, very high risk. That is when these global events of impact become very regular and basically undermine the resilience of these systems to recover from those impacts. And what you can see here immediately, as the title says, that every degree of warming matters. You can also see that there are important shifts between where we are today and 1.5, and then further between 1.5 and 2. You can look here at the left-hand bar for the unique and threatened systems, where there is a clear shift between moderate to high risk between where we are today and 1.5, and then further to very high risk for 2 degrees. And I think for context, it is maybe interesting to look at this in a bit wider perspective. And this is a very provocative title. The more we learn, the worse it looks. And I will draw here on the sequential IPCC reports that have been published with this figure. And we had a report in 2001, the third assessment report in 2014, the fifth assessment report, and now the IPCC special report of 1.5. And I'm just here with this, I'm highlighting the area between 1.5 and 2. And you can see in each of these reports, the scientist or the IPCC assessed the risks based on all available evidence. And I think there's some clear shift you can already see from the color, that risks are assessed to be much higher for the same amount of warming. And particularly here in these 2 last bars, where in 2001, for global impacts and also for the large-scale singular events, the risks were actually assessed to be undetectable. Whereas today, if you look at the 2 bars there, they're already on the verge between moderate to high. And so it clearly shows a shift in our assessment of the risks with more evidence that we get, or more scientific evidence that becomes available. Now, I want to go back. Yes, there we go. Fortunately, the report also was able to figure out from the scientific evidence what needs to be done. First of all, emissions today, so the emissions that we have put into the atmosphere today, do not commit us to cross 1.5 degrees of warming. To halt warming, CO2 emissions need to be brought to zero, and non-CO2 forcing needs to be also decreased. And so that basically means that we have a carbon budget, and that's here. This is not an IPCC figure. That is just a hand-drawn sketch, but it means, but it shows global CO2 emissions over time. The IPCC, drawing on work of the Global Carbon Project, has assessed that we had emitted 2,200 billion tons of carbon dioxide until 2017, and we have a carbon budget to limit warming to 1.5. And the implication of a global carbon budget, if we want to stay with that, is that global emissions need to get to zero. How large is this budget? Well, it's not that big. Limiting warming to 1.5 means that there is 420 or 580 billion tons of carbon dioxide left, starting to count in 2018. And the previous presenter showed that in 2018 and 2019 as well, we have been biting decent chunks of that carbon budget. The report provided some good news. Compared to the previous assessment, the remaining carbon budget for limiting warming to 1.5 was slightly larger than assessed in 2013 by the fifth assessment report, but also some bad news, better understanding of Earth system feedbacks. For example, the thawing of the permafrost would actually further reduce those numbers by 100 billion tons of carbon dioxide. As I mentioned before, it also matters what we do on non-CO2, whether we reduce our emissions of methane strongly or less strongly, and this can also still impact those numbers or the remaining carbon budget to an important degree. So we really want to be looking at all gases, at all greenhouse gases. Some of them need to go to zero, others not. Now, this is a geophysical limitations within which one ought to stay when one wants to limit warming to 1.5. The report also looks at how this then can be implemented. And here you can see again CO2 emissions over time and of pathways that basically model societal transitions. And there are a few key characteristics. The first key characteristic is that they all start reducing emissions in this decade. By 2030, emissions in those pathways are 45% below 2010 levels. I think that is clear that with the budget that we have available, if you wait, it would just be used up. They reach net zero around mid-century. You can also see that there is some variation, but the clear trend or the destination is clear here. And then finally, in the long term, they use different amounts of carbon dioxide removal, which I will come back to later. Non-CO2, you heard about methane, black carbon or soot or nitrous oxide. Also, those emissions are reduced, but they don't reach zero globally. The reason why they don't reach zero globally is because in all the literature that was assessed, we have currently not identified mitigation measures that can really eliminate them. If one could eliminate them, one would also want to eliminate them. But unfortunately, there are still important residual emissions both from methane and nitrous oxide linked to agriculture and activities that basically sustain our life as a species. So how do we achieve these emissions reductions? The IPCC came up with a rather general, but I think also a quite clear statement. It says limiting warming to 1.5 would require rapid, far-reaching changes on an unprecedented scale. And each of these words in bold here, they have a particular meaning. So rapid means really in the next decade. You could see that from the previous slide. By 2030, things must have happened if we are serious about limiting warming to 1.5. Far-reaching is really that every part of our economic or societal activities need to be involved. The way we produce energy, the way we use the land for agriculture, the way we build our houses or we design our cities, or also the way in which we produce the products that we use. And then finally, unprecedented scale is that we need to see stringent action in each sector. There is no one single sector that can just lay back and, for example, the power sector can decarbonize and the agricultural sector can just sit back. Now I come to the last part of my presentation, where the IPCC also showed that not all pathways not all strategies are created equal, and it illustrated that by using 4 illustrative pathways. And what each of these figures show is again carbon dioxide emissions, but a breakdown now, which by pure coincidence, matches somehow the color scheme that was, presented in the global carbon budget. Gray is fossil fuel and industry emissions. Brownish is emissions from agriculture, forestry, and other land use. And the yellow area below is carbon dioxide removal by means of bioenergy with carbon capture and storage. And each of these pathways, particularly those three, they limit warming to pretty much the same temperature. But as you can see, they do so in very different ways, and in ways that rely more or less on bioenergy with carbon capture and storage, and that is because they pursue very different strategies. So even when having decided that one wants to pursue a very stringent goal, the 1.5 degree report also shows that there are important choices to be made about the strategies that are followed to do that. And the reason why this is important is that these mitigation choices, they matter for sustainable development. The report was able to identify many synergies between climate change mitigation and sustainable development, but also potential trade-offs. And the strategic choices that are made in terms of which climate mitigation measures are implemented really determine whether this will support or undermine sustainable development. Generally speaking, many synergies can be found with strategies that try to limit energy demand or limit demand, both in energy or materials and land use. Finally, the report also clearly pointed out that current pledges of countries are not on track. I won't say too much because the entire next presentation will be about this. But more importantly, the question then becomes, is this feasible? And the IPCC was asked this question and came back with a complicated answer. The IPCC found or identified 6 dimensions of feasibility, and you can see them here: geophysical feasibility, environmental feasibility, economic feasibility. And for some of those dimensions, we as scientists, we can easily tick the box and say that, that this is possible. For example, we can say that within the laws of energy and industry, of physics and chemistry, we can limit warming to 1.5. We can do that within the confines of our planet. We have the technologies to do that. The report shows that. And also from the economics, this would not be a overarching cost. However, these two factors here at the bottom, these two dimensions of feasibility, the institutional feasibility is whether we have the institutions in place to help this transformation, and the social and cultural feasibility, whether society is willing to make the behavioral changes and to make the mitigation choices that are required to do this, to make this transformation, are two boxes that we as scientists, we cannot tick. And being here is really nice because I can now point to the room, or probably not the people that are sitting here in this room, but people further down the corridor for their decisions, because their decisions matter here for those two dimensions. Thank you.
Oops, sorry. Thank you very much indeed for that. As most people here in this room know, the IPCC is co-sponsored by WMO and UN Environment. It's, we hope, a successful partnership, a successful family. And so here to complete the circle and give us the full picture of what's happening on greenhouse gases, I'm pleased to announce Anne Olhoff, who's head of strategy, center planning and policy at the UNEP DTU partnership. UNEP every year releases a very highly regarded, much awaited emissions gap report. And as I'm sure Anne will tell you, this year was the 10th anniversary of that report, and it very much complements what WMO reports on the greenhouse gas concentrations, and the findings, obviously, of all these reports are not exactly what we want to hear, but more of that from Anne. Thank you.
Thank you, Claire, and thanks for inviting me to present here today. I want to start by thanking WMO in particular for convening us all under this United in Science voice. We started doing that for the Climate Action Summit in New York earlier in September this year. And I think it's really important for us to come together and speak more as one, all the different organizations that provide scientific foundations for the negotiations, for actions by countries, and so forth. So as Claire already said, we just published the 10th emissions gap report last week in Geneva. We've been doing this ever since Copenhagen, the Copenhagen Cup, which you may all remember. Everybody hoped we would get a global deal. We didn't. But at least countries started putting forward climate mitigation pledges. And with those pledges, a central question arose whether those pledges were sufficient to bring us on track towards 2 degrees at the time, or whether there was a gap between where we would be heading if countries fully achieve their pledges and where science tells us we need to be in terms of global emissions. So that's one central question the report addresses every single year. Where we're headed under current climate pledges compared to where the science tells us we need to be. And of course, with the Paris Agreement, these targets have now been strengthened to well below 2 degrees and pursuing 1.5 degrees. The other central question that the reports look at is, can we bridge this gap, this difference between where we're headed and where we need to be, and what are the opportunities to do so? So although it does look bleak, and previous presenters already showed that very clearly, there are also opportunities. The thing is to scale those up and accelerate and implement them at a far larger scale than we have done so far. So these are the main questions of the report. We look at the trend in global GHG emissions and also CO2 emissions, where we're heading. We have a specific emphasis on G20 economies and their current policies and whether or not they're on track to meeting their nationally determined contribution commitments or targets, and what that impact of these NDCs, if they are implemented, what that will be. We compare that to whether that is sufficient to stay well below 2 degrees and to pursue 1.5 degrees, and the difference between the two is the gap. And then, as I just said, we look at if and how the gap can be bridged. I actually thought I included a slide because, as the previous presenters, this is an assessment report. So we're sort of adopting, you could call it a mini IPCC approach, whereby in this year we had contributions from 57 authors based in 33 institutions across 25 countries, and both of the two previous presenters are among the lead authors of the report. So if you have very detailed, specific questions, I'm sure they can also help you answering those, and help me in particular. So here we look at what has happened in terms of global emissions over the past decade, and what we see is that there's been an annual increase of 1% per year over the past decade. Glenn already went much into detail with this, so I won't go more into that. But what we see basically is, if I can get this to behave, that as yet we don't see any signs of global emissions peaking. We see that emissions continue to increase, although at a lower rate than the previous decade. We have reached another record, another year, another record, as the previous presenter said. And if we compare the emissions reductions required to get on track towards 2 and 1.5 degree, respectively, if we compare that to current emissions, we now need to cut emissions by 2030 by 25% for the 2 degree limit, and by 55% to get on track towards 1.5 degrees. If we go dig a bit deeper, and this is actually one of Glenn's great figures, we can see that what are some of the major drivers of the annual growth rates in CO2 emissions. And what we can see is that increasingly these are explained by differences in economic growth rates. And here we show the differences between OECD countries and non-OECD countries. So basically, driven largely by economic growth in non-OECD countries, which has basically induced a great increase in primary energy as well, although the energy intensity is lower, the carbon intensity is also, there have also been progress, but overall emissions have continued to grow. Oh, I have to do the trick. Then we look at whether or not G20 countries are on track with their current policies to actually achieving the targets they've set for emission reductions in 2030. And what we can see here is that 6 countries are on track to achieving their NDCs or their NDC targets with current policies in place: India, Russia, Turkey, China, the EU 28, and Mexico. While we have 7 countries that are currently not on track to achieving their NDC targets, and for 3 countries, we simply don't know based on the available information right now. So it's difficult to rate countries based on this, because you can have a very ambitious NDC target and not be on track, but still it's ambitious, or you could have a very unambitious NDC target, and then it's not so difficult to be on track. We don't rate countries in the emissions gap report, but it's quite clear that if you are already on track to overachieve your NDC target by more than 15%, it would be quite cheap to raise ambition. You would actually not have to implement more policies to do so. Let's turn to what the latest assessment of the emissions gap is this year. And basically, it hasn't changed much compared to last year, and that's simply because last year we had a huge update based on the IPCC special report for especially the 1.5 degree range. So that changed a lot. Not a lot has changed on that side, on the scientific side, since the IPCC 1.5 degree special report. Not a lot has changed on the NDC front, but we hope that we will see major changes next year, and we all need to push for that, of course. And the current policies, there's slight progress, but still no major changes. So overall, that means that the gap remains more or less the same. What we can see here on the first slide is basically the top line, what's called the 2005 policy scenarios, tells us where would global emissions be and be headed if we hadn't implemented any climate policies since 2005. So that's the no policy baseline, or the business as usual scenario, if you wish. Then we look at how are we doing, or what are the estimated emissions based on current policies in place. And you can see already that there's a difference between the no policy and the current policy scenario. So we have reduced, or will be reducing, global emissions around 4 gigatons of CO2 annually by 2030, just by doing what we're doing today. If we then move to the unconditional and conditional NDCs and what they imply in terms of global emissions, we can see that that further reduces where we will be in 2030 if they're fully implemented. But again, there's quite a big distance to get on track and become consistent with 2 degree and 1.5 degree pathways. So basically there is a gap, and now I have to do the little thing again. There's a gap in 2030, an emissions gap of between 12 to 15 gigatons of CO2 equivalents per year if we consider the 2 degree limit, and that increases to between 29 and 32 gigatons of CO2 equivalents per year if we want to get on track towards limiting global temperature increase to 1.5 degrees. So basically more than half of current emissions we need to shave off in the next 10 years. So just to sum up, if we continue on the path set by the ambition level in the current NDCs, we are on track to a temperature increase by the end of the century of around 3.2 degrees Celsius. And that can be lowered to about 3 degrees Celsius if the conditional NDCs are also implemented. What we've focused a lot on and emphasized a lot this year is that every year that we postpone action means that deeper and faster cuts will be required to basically achieve the Paris Agreement goals. And basically we're on the brink where we can no longer postpone action. We put out in another way of expressing these emission reductions that are needed and the rate at which they're needed this year was that basically from next year, from 1 month, in 1 month, and then over the next 10 years, each year we have to reduce global emissions by 7.6%. That has never been done before. It's maybe happened in specific times of wars or deep economic crisis, but we need to do it. And another way of expressing what we need to see happening next year is that compared to the current ambition level in the NDCs, we need to increase that 3 times to get on track to 2 degrees. We need more than a 5-fold increase in current level of ambitions to get on track to 1.5 degrees. Then we look at what are some of the options for ambitious climate action, and we focus again specifically on G20 economies because they account for 78% of global emissions, but we also look at action at country level and regional level in cities and states and so forth. And this is just to show you one of the areas that we focus on. Of course, it's going to be the overarching focus and also looking out to 2050, where Shuri said we need to be on around zero emissions. So we look at what is the current status. And what we see here in the G20 countries is that we have 2 G20 members, France and the UK, that have already passed legislation. And then we have 3 G20 members, which is basically the EU, and then Germany and Italy as part of the EU, who are currently in the process of passing legislation. But the rest of the G20 members, if you count the EU 28 as one, they don't have any binding targets, zero emission targets in place yet. Currently, we saw quite a big increase, actually, before and after the Climate Action Summit in New York. So we have 71 countries that have committed to some sort of zero emission target further out in the future, in this century. But they only account for about 15% of global emissions. So we need to get that percentage up very fast and quickly. And what's equally important is that even if some countries are now coming out with these very strong commitments, setting the direction for the future, it's very clear. Is that me? It's very clear that countries do not yet have the policies in place. They don't have the roadmaps clear, and that's where the NDCs for 2030 is of great importance. So basically, it's good to have a 2050 or whenever target for zero emissions, but how do we get there? I'm from Denmark, and this year the government set a target of reducing emissions by 70% in 2030. That's probably a good target. Now they're trying to find out how the hell, I was almost going to say, they're going to achieve that. But I think that's a good example that we need to set a bold targets, and then we need to find out how to actually achieve it. So we look into all these different areas where what would ambitious climate action policy look like that would be aligned and consistent with the Paris Agreement goals? What is the current status? And what are the most immediate opportunities for countries to enhance their ambition next year in line with what is required to achieve the temperature goals of the Paris Agreement? And just to summarize, what we see is that we have more opportunities and incentives for ambitious climate action than ever before. So there's a good basis for basically boosting and enhancing both your NDC ambition and action. We also see that transformations are beginning to happen in some countries, in some places of the world, in some areas and sectors, but it's still very small scale, and it needs to be significantly accelerated and rolled out at G20 level for us to bend the global emissions curve very quickly. And then we look at some of the concrete steps that each of the G20 members can take. So basically, we need to move away from incremental change, from small progress to transformational change. And we include a chapter in the report this year that looks into what does that look like, what does it imply, and also that it's fundamental that this has to be designed in a way that ensures that it brings multiple benefits, both for humanity and for planetary support systems. And we look into 6 major transformation processes that can actually support both the climate goals and other goals and priorities. So for air pollution and health, urbanization, governance, and so forth. And just to show one example in digitalization, a good example is the transformation that's actually happened over the last few decades with the advances. So today most of us have something that looks a bit like that mobile gadget over there, and it actually can can provide all the functions of all the old gadgets over there on the other side in a much more efficient way, in a much less energy consuming way, and with much less material consumption implied. One of the areas that is going to be super important and really critical over the next decade is how do we transform the global energy system. And we look into sort of 5 headings, and the first one is easy wins. They're not that easy in practice, of course, but at least expansion of renewable energy is an area where there's great progress. I'll show you a slide on the next slide to exemplify this. We need to have coal phase out, otherwise we will have passed the carbon budget limit for 1.5 degrees before 2030. We need to find out how we decarbonize transport, and of course there's already been huge advances just within the past decade on that aspect. And then we need to work on how we address the more tricky areas and sectors, including energy-intensive industry and so forth, where it's not so easy to electrify it. And then finally, but not least, we need to make sure that we do this in a way that leaves no one behind. We need to do it in a way where people can get access to the basic needs that they require, but we need to do that in a way where countries and populations avoid making the same mistakes that some of us have and some of our countries have already made. And that's entirely possible, but it does require a major transformation. So just to illustrate the easy wins, I'll show here the development just from 2010 to 2018 in global levelized cost of renewable energy. And people, you often still hear the argument that renewable energy is much more expensive than fossil fuel based. But if you look here, there's been tremendous cost decreases just within this very short time frame. And in most places around the world, renewable energy is fully competitive with fossil fuels. We also see for the past couple of years that investment in renewables have been at least at the same level as investments in fossil fuels, and in many places above investments in fossil fuels. But of course that also needs to happen even more quickly than it's currently doing. Then as a final topic that's often overseen in our community, but not in life cycle assessment and so forth, of course, we look into material efficiency this year. If you look at the greenhouse gas emissions associated both with material production and the first use of material, it's actually more than 1/5 of global emissions right now. So there's a huge area for thinking more efficiency into the process that can also contribute important emissions reductions. We look into 2 areas in the report. One is vehicles, and that's what I'm showing here. Some of the different ways and the different approaches to achieving emissions reductions in passenger vehicles for the G7 and for China and India, and showing pretty significant decreases. And we also look into similar opportunities in buildings. So just to sum up the answers, I don't have to go through all of them, of course, but the main questions I shared in the beginning, we see that global emissions continue to rise. They show no signs of peaking right now. We see NDC targets that G20 economies are not yet on track to achieve. We see a huge gap between what the NDCs imply in terms of global emissions in 2030 and where science tells us that we need to be. We're currently on track to 3.2 degrees rather than well below 2 and 1.5. But there are plenty of opportunities. There have been very positive developments, especially in renewable energy technologies and in electrification. We just need to accelerate that development and to really bring about the changes that are needed, and we need to do so very rapidly. So we need hugely increased ambition in the NDCs next year, but equally or more importantly, we need to see that backed up by immediate action, and we shouldn't wait 1 month or 1 day. We need to start right now. Thank you very much.
Thank you very much. And as Anne said earlier this year, ahead of the UN Climate Action Summit, the organizations represented in this room joined together to produce a United in Science report to inform policymaking. And we hope both the United in Science report and all the individual reports which have been produced in the last 2 weeks will indeed, spur the negotiators here into living up to the motto of the conference and time for action. So with that, if we have any questions or comments, the floor is open. And do you want to do this?
Yep. Okay. I have a question. In all these calculations, 1.5, 2, they imply a lot of human decisions that have to be taken. Now, assuming we take those decisions, let's assume we get to 1.5 with the proper decisions. Now, how confident are you that the temperature is going to stay there? My question is, what about the positive feedback effects from the planet? Like methane hydrates from the eastern Siberian Arctic shelf, for example? Do you think that wouldn't be that important?
Yeah, I can maybe... So we looked exactly at this in the IPCC report, and there are reinforcing feedbacks in our planetary system, and these are also included in those estimations of, for example, the remaining carbon budget. One example of this that I presented was the 100 billion tons of carbon dioxide that need to be removed in addition during this century. Now, this is from permafrost thawing. Permafrost will continue to thaw, so that means that also in following centuries, there might be a requirement to actively remove carbon dioxide from the atmosphere. And these feedbacks can indeed increase the risks. However, that doesn't take away that the first step is clearly that the first step is still very clear from the scientific evidence, and that is that global carbon dioxide emissions should be brought to zero, and that is a very important first step in stabilizing the climate.
Thank you, moderator. Anna mentioned transformative changes necessary, but I have a question to the author of 1.5 report, because the report mentioned about the capacity of transformative change. So could you describe the definitions and the examples of capacity of transformative change?
Yeah, unfortunately, I would love to. But that's unfortunately not the chapter I was coordinating, so I would feel very uncomfortable giving a... But actually on the previous panel, there was Helene de Koning, who was coordinating chapter 4, that indeed provided all the assessment and the context of those concepts. So sorry, I can't answer that one.
I don't have the definitions per se, but well, we got the answer. So can I borrow your mic? So when we launched the report last week in Geneva, we got a lot of attention from the media. We've basically been talking to almost all major media outlets around the world. So there's huge interest, and a lot of the questions were around: is it possible to achieve these 7.6% emission reductions per year globally? And it's a good question. And what does it require? And I think we've looked into also in previous years, is it technically and economically feasible to achieve or to get on track towards 1.5? And the conclusion so far has been yes, but now it's increasingly yes, but barely, and really requiring everything to happen right now. So I think the key issue, and that's also what a lot of the media attention has been focusing on, is just to explain that right now, as we can see from the previous presentations, there's still lots of stuff where we could gain more knowledge and learn more, and there are gaps in our scientific understanding and so forth. But we really know enough. We know where we're headed, but we also know what the opportunities are, and what we are not very good at, and what is probably the most difficult is to find out how do we actually accelerate the change and transformational change at the scale needed. So I think that's where we need to focus a lot. How do we actually bring this about? What works when, where, and when, and what is needed in different places around the world to facilitate this? How do you design policy packages that gets populations behind you rather than against you, as we've also seen with minor increases in fossil fuel prices or even metro tickets and so forth. So to me, if we want to make this change rapidly enough, that's where we need to focus on how do we actually do that.
If I just add on to that, it also addresses a little bit the previous question as well. To a degree, we're taking a bit of a step into the unknown. Now, what does it mean to deliberately reduce emissions at such high rates in a sort of engineered way? So previously, we haven't deliberately tried to reduce emissions. Maybe 7.6% is too hard. Maybe 5% is comfortable. But our emissions are still going up, so you can't even say that we've even tried to reduce our emissions. So I think the number one issue is to get moving on the right track, so get emissions levelling out, then getting them down, and maybe it's a lot easier than we thought. And coming back to the IPCC, the 1.5 report, every year matters, every degree matters, every year matters, whatever. So, you know, even if we get temperatures down to 2.2 at the end of the century, it's better than being 3 degrees. Or if we get down to 1.7, it's better than 2 degrees. So, and that applies to the feedbacks as well. The risk of feedbacks will be much lower the lower the temperature goes. We don't really know when feedbacks may kick in and how big they are. So it just comes back to the simple thing. We have to stop emissions increasing. Once they stop increasing, we have to get them going down as fast as we can.
Hello, hi, thank you very much. As a person trained in science, I was trained in biological science and then computer science and a little bit of math. I fully respect the work the scientists have bring to this particular debate. And I think that, as Anne said earlier, we've now reached sort of a pretty solid consensus that the prediction figures are what they are. In my conversations here at COP25, I've had a few conversations with people from the UN. And one comment I've heard, and is not sort of any particular negative thing about science, is that they say, and I want to hear your feedback on this, that the reason we've had such little progress is because COP itself is intrinsically convened by scientists. And as a result, the DNA of COP actually does not contain enough of the people who are skilled in the arts of political craft making in order to sort of achieve certain goals. By contrast, right, the conferences convened by the oil and energy lobbies are extremely well populated by people who are very good at influencing public opinion. They've actually been trained for 2 to 3 decades in doing that precisely. And so thinking through some of the sort of models that have been presented, very eloquently on stage, I have 2 ideas. The first idea is I want to see if it's possible to crowdfund, let's say like $3 million US in order to create some sort of consumer application that basically takes these models and turns it into a daily, like, sort of ticking time bomb of carbon budget decrease. And then find ways to get, Apple, Google, Facebook, and all these other major tech companies that have distribution to distribute them to, let's say, like 3 billion people, right, in the span of like 2 years. And I think if we manage to do that, then the science, and then also on top of this, right, create actually a real-time publishing channel where if you guys actually come up with additional models and additional supplementation, then we sort of just update what's shown on screen. Because I think one of the big challenges that I see just coming to COP for the first time, but being very interested in this for almost a bunch of years, there's very little dissemination from these slides into the public consciousness of anyone outside of, let's say, like 1 million people who've attended COP. And I think that we really need to sizably scale the sort of direct-to-people interaction. That's the first comment or question or suggestion we'd love to work with you guys on. And then the second is, from your own opinion, like what has actually meaningfully changed since either the Paris Agreement or the NDCs? Like, have you actually, the scientists here, had conversations with politicians or any policymakers driving NDC, development? And have you actually confronted them with the inadequacy that the NDCs have shown in especially the G20 countries? Thank you.
That's a really good question and really good observations. I think on the first issues raised, I think one of the mistakes here is that I totally agree with you. We need to become much better at communicating to other audiences. I think the COPs are an example where we've primarily seen this within the whole environment agenda and not within mainstreaming it into main ministries, line ministries, finance and so forth. I think that has changed gradually, but that, to me that is more the explanation rather than that we haven't, that it's been driven by scientists, which I don't think is true. On the outreach side, and you mentioned the app, I think what's really, really important is that we don't just scare people. Because as I've also been saying in all of these interviews we've been conducting over the past 2 weeks, this cannot be just shifted, the burden cannot be shifted onto us as individuals or as consumers. We require such fundamental transformations that we need the structural changes from the highest levels possible. So you can't just scare people, you need to provide them with solutions, you need to guide them in the direction, what is it then that we should be doing. Just based on the emissions gap experience, it's the 10th time this year, and I think we've been on a steep learning curve. So the first 5, 6 years maybe, I don't think we were very effective in our outreach, but now we basically reach out globally with the media launch, with the global launch, and it's getting attention from all corners of the world. So in principle, all people around the globe have access to this information. We follow up with bilaterals. So for instance, we are going to have a briefing of the European Parliament members next week. And we have done that with basically all delegations who have asked for it. We even did some years ago when apps just came out and were, the hot stuff. We did a gap app. So I mean, we are trying, but we can learn and become better.
Hello? Yeah. I would just like to add to that. I totally agree with what Anne said. And also, there has been a lot of communication also before, which was a lot directed into scaring people and forecasting the end of the world. And it's shifting more towards solution-based, that really solutions are showcased. And I think this is the direction to go. So, because if I'm only scared, I cannot even do something. But then if I get a solution presented, then I can possibly act on that. And to just add on that, there's also more and more partnerships coming up or intensified. For example, we as World Meteorological Organization have just intensified our partnership with the World Health Organization to work together on the impacts that will affect people, on climate impacts such as heat waves and so on, and also on air pollution impacts, to go into the direction to tackle all of these together and to provide services and warnings related to that. So, yeah, and I'm sure there are many more examples like that. So this is the things that are going on right now. So that's to your question, if we can see things that are moving.
Right, I don't want to cut this too short, but we are under pressure time-wise. Glenn, did you want to add anything? And then we just have time for one last question from that lady over there, and then I think we have to clear the pavilion for the next person. Thank you.
I wanted actually to make a comment because I'm from Chile, and as you all know, we should be in Chile, not here. So that has something to do with transformation, I think. But towards your comment that this is a science-driven process, I think it's not. That's one of the problems. It's not really a science-driven process. I mean, we scientists provide inputs, and that gets somehow taken up. It does get taken up by the convention. But the negotiators, I don't know if you've been, they're very, very far away from here. Physically very far away. They don't come here. That's one of the problems. And how can we really make progress? I think we are starting to see in this process that we really have to engage a lot more than just negotiators and scientists. And this year there will be a meeting of transport ministers, of finance ministers. It's the first time that that is happening. And I think that's quite crucial actually, because at the end of the day, those are the ministers who decide where we're going to spend the money and how we're going to align that financing flow. Later today, there will be a meeting of science ministers as well. So we really need to stop just discussing these things between our environmental ministers in the countries, but involve all sectors, because as it was said, if we want to reach this goal, we have to involve all sectors of our society.
Yeah, maybe I just want to echo all the comments that my colleagues made, but I also want to give you one positive example where of the UK, where my institution or where I come from, and where policymakers and politicians do listen to the science. They have a separate committee, the Committee on Climate Change, that has taken up the insights and the assessment of the 1.5 degree special report. Based on that, provided new evidence to government and new recommendations to government, which have led the UK to adopt now a net zero greenhouse gas target by mid-century. So this is one of the positive stories, I think, where at least some of the signs of the new insights and the new assessments lead through to decision making. But ultimately, it is also important that such a process is put in place, and not every country has such a process. There are countries where even science is not a topic. So.
I can just make a real quick comment. It's and builds on what was just said here. It's there's no one individual that can do everything, and there's no one way to do it, and it's not just an example, the oil industry does this and therefore that would work. There's always a different context and so on. You know, maybe, and most people, you know, let's say scientists, they're already got full-time jobs. Their jobs are not to go out and track down policymakers and say, why aren't you doing this or whatever. Even though many of us do speak to various policymakers and so on. But I just would make a couple of comments. So I'm originally from Australia. Our minister responsible is very good at finding every little way that, well, in this quarter our emissions went down. You're looking at the long-term trend, emissions are going up. So politicians are very good at talking the talk. They can convince their constituencies that they're doing an absolutely fantastic job. And so society, I'm not going to point fingers at anyone who, is not very good at calling them out. They get away with it. Norway, many people where I currently based and work, well, everyone thinks Norway is the climate leader, the greatest country in the world when it comes to climate. Their emissions are going up. Norway, for whatever reason, has become very good at convincing the world that they're doing a lot on climate. Electric vehicles, look how much into electric vehicles, or the Amazon fund, look how much we've put into deforestation. Meanwhile, Norwegian emissions are going up. Again, where's the pressure? Calling them out. They get away with it. Politician, we reduce our emissions, they're out the next term. They don't get any punishment for it. You could also say through boards of businesses and so on. There's potentially avenues in the future where they could be legally caught up in, yeah. So, and just coming back to this question before, different ministries have different responsibilities. An environment ministry might have responsibility for climate. They're not pulling the financial measures, so they can't implement taxes or anything like that. That's in the finance ministry. An oil ministry or an energy ministry has a different set of incentives, and so getting these ministries to work in the same direction is a very difficult achievement. There's no golden solution, but somehow everyone lifting. It's not easy, otherwise if it was easy we would have been done by now. So.
Thank you very much. And unfortunately, we've run out of time, but thanks very much indeed to our distinguished panel. Thanks to the audience. Thank you for making time on a busy day to come. So thank you very much indeed.